If you're in the Kubernetes world, you know it is always evolving. I mean, it never stands still. The latest release, version 1.35, is absolutely packed with updates. But let's be real, which ones actually matter for your day-to-day work? Well, this is your shortcut to the 5 biggest changes that are going to improve your day 2 operations. So let's dive right in.
So here's what we're going to cover. First, we'll quickly set the stage on what's new for day 2 ops. Then we're hitting our 5 headliners. Seamless vertical scaling, much tighter security controls, smarter network traffic routing, a declarative and frankly way better way to manage off, and finally, a really cool new method for using images as data volumes. Let's get to it.
So what is the big theme for Kubernetes 135? It's really all about making our lives easier after the application is already deployed. We're talking about day 2 operations, the real world stuff, the challenges of actually running apps in production.
Yeah, day 2 is everything that happens after the launch party is over. It's the real world of running live applications. You're managing them, you're maintaining them, and you're constantly trying to optimize them. The 5 features we're about to cover are specifically designed to solve those exact headaches that come with running Kubernetes at scale. All right, first up is a feature that is, and I'm not exaggerating, an absolute game changer, especially for anyone running those long-lived, stateful applications. We're talking about seamless vertical scaling through in-place pod resource updates.
I mean, this is such a dramatic shift. Before, if you needed to give a pod a little more CPU or memory, what did you have to do? You had to kill it and restart it. That meant downtime, and for stateful apps, oh man, that could mean data rebalancing nightmares. But now, with version 135, you can resize those resources on the fly for a running pod. No restart, zero disruption.
The impact this has on your most critical applications is just huge. This finally enables true vertical pod autoscaling. It protects those stateful services from painful failovers. And for all you AI and ML folks out there, this is massive. It preserves your in-memory caches and your model checkpoints, which prevents those frustrating interruptions during long training or inference jobs.
Okay, let's pivot to security. This next feature helps you create a much tighter security posture, especially if you're in a shared or multi-tenant cluster. We're talking about fine-grained group control. This really shifts security from being a blunt tool to more of a surgical one. It used to be that every container inside a pod got the exact same set of supplemental group permissions. So if one container needed special access, guess what? They all got it, a clear violation of the principle of least privilege. But now you can assign specific groups to individual containers. It sounds simple, but it's incredibly powerful. So why is this a big deal? Well, it dramatically enhances security and isolation, especially when you have multiple teams sharing a cluster. It helps you properly lock down access to shared storage, and if you're in a regulated industry, say finance or healthcare, this feature is absolutely critical for meeting those strict compliance benchmarks, like the ones from the Center for Internet Security.
And you know what? Implementing it is surprisingly straightforward. You just choose a policy right in your pod's security context, something like strict mode. Then you define the exact groups each container needs. Kubernetes just handles the rest, making sure there's no accidental permission creep between your containers.
Okay, next up, let's switch gears and talk about network performance. We're going to look at a pretty simple change in how services route traffic that can have a massive impact on the speed of your microservices. Just ask yourself this. In your microservices architecture, how many of your requests are taking an unnecessary trip across the network to another node? Because that adds latency every single time. It's this huge, often hidden performance killer. So here's the fix. Before, kubeproxy would just send traffic to any available pod for a service, even if that meant a slow cross-node hop. But now, you can set a policy called Prefer Same Node. Kubernetes will then intelligently try to route traffic to a pod on the same node first. It only goes across the network if a local pod isn't available. It's a simple preference, but boy, is it a powerful one. And the benefits here are really twofold: speed and cost. This is a massive win for those chatty microservices, like API gateways, and it cuts down network overhead for service meshes like Istio. It also improves performance for things like node local caches. And this one's a biggie. It can actually lower your cloud bill by reducing those cross-node data transfer fees.
All right, let's talk about cluster administration for a minute. This next feature is all about bringing sanity, predictability, and just modern best practices to how you manage authentication for your entire cluster. This is such a beautiful change for anyone who loves GitOps and absolutely hates configuration drift. The before world was, well, a mess of command line flags on the API server. They were hard to track and way too easy to mess up. The now is a single, clean, versioned YAML file that pulls everything together. OIDC providers, webhooks, you name it. It's declarative, just like the rest of Kubernetes should. And for cluster admins, this is a dream come true. You can now manage your authentication config using your favorite GitOps tools like Flux or Argo CD. Every single change is auditable in a pull request. This dramatically reduces the risk of security misconfigurations, and because the config is a versioned API, it makes cluster upgrades so much smoother.
Okay, let's get to our final feature, and it is a really clever one. It completely rethinks how we can bundle and distribute data to our pods by leveraging the tools we're already using every single day. The core idea here is so simple but so powerful, separating your code from your data. On the left, you see the old way. Bake everything, your ML models, your web assets, whatever, into one giant bloated application image. It's slow to build, it's slow to pull. But on the right, that's the new way. A small, lightweight application image, and then a separate image that just contains your data, which then gets mounted as a read-only volume. And the use cases for this are just fantastic. I mean, think about it. Versioning and distributing machine learning models directly from a registry like Hugging Face, or shipping content bundles for your web apps. You could even use it to share common config files or utilities in your CI/CD pipelines. You're basically using the container registry you already have as this powerful, versioned file distribution system. It's brilliant. Okay, let's bring it all together. Here is your at-a-glance summary. In-place pod updates. They solve those disruptive restarts for seamless scaling. Supplemental Group Control. That tackles overprivileged access for granular security. Prefer same node traffic reduces latency. Structured auth config replaces those error-prone flags with GitOps-friendly YAML. And OCI image volumes fix bloated images with decoupled data management. 5 key problems, 5 really elegant solutions. So there you have it, the 5 features in Kubernetes 135 that I think will have the biggest impact on your day 2 operations. And these aren't just minor tweaks, they are powerful new tools for building more resilient, more secure, and more efficient clusters. So I guess the only question left is, how are you going to use them?